Hi guys, welcome back. I know earlier this week we used some College Board videos to help you with the product and quotient rules, and they were fine. I think the College Board did an okay job there. This next idea is really important though, and it's not that I don't trust them, but well, I didn't trust them to do this one very well, so I'll be honest. Because today's topic is all about something called the chain rule. The chain rule is how we handle composite functions. So we've had, products and quotients and sums and constant multiples and the power rule and all that stuff. But what we're talking about today is what happens if we have function inside of another function. And we see this a lot. We're going to be using this rule, the chain rule, quite a bit for the rest of the year. So I wanted to really take some time and go over it with you. So for us, for the chain rule, okay, I'm going to define a function right now. I'm going to define h of x, okay, and it's going to be a composite function. It's going to be f of g of x, okay. And so what I want to do is I want to find the derivative of that function, h prime of x. And of course, we know what that means. That means the limit as delta x approaches 0 of h of x plus delta x, right, minus h of x, all of that over delta x. So what I'm going to do here is I'm going to use the composite definition for h and sort of expand this out. So what I get is the limit as delta x approaches 0 for f of g of x plus delta x minus f of g of x. Okay. And oops, forgot a parenthesis right there. Right there. And that's all going to be over delta x. Now, I'm about to multiply by a factor here, and it's going to look a little weird, okay? But I want you to think about this. The g of x plus delta x and g of x, those are kind of the inputs into the function f, right? So what I'm going to do is multiply by g of x plus delta x minus g of x over itself. Okay. Now, this is where this gets a little interesting because I'm going to split this fraction up in a different way now. So I'm going to it's still going to be the, oops, forgot to change the color there. It's still going to be the limit as delta x approaches 0. And my numerator is still f of g of x plus delta x minus f of g of x, okay? But here's what I'm going to do. I'm going to split the fraction up a little bit differently. Okay, I'm going to bring a g of x plus delta x minus g of x. And then over here, I've got g of x plus delta x minus g of x. And in the denominator now, I'm going to move the delta x over there. Okay? Now I got to go on to the next page here. So I'm going to flip the page, but I'm going to bring this guy back over with us. So hang on while I rewrite it. So I got the limit as delta x approaches 0. And I've got f of g of x plus delta x minus f of g of x just so I can do this all at once. And check out what happens here, guys. I think we all recognize this here, right? You guys see what that is? Isn't that really just G prime? Right? Yeah, that's just, oh my. Try that again. This is just g prime of x. Now, this first term over here, this is interesting because what we're really looking at right here in this term, guys, is if you notice, it kind of looks like a derivative, right? We have f of a quantity minus f of a different quantity. So that's the difference in y coordinates, right? Over the difference of those two quantities that we inputted into the function f. Okay, this is really, if you think of g as of x being like an input, that's like an x1, and g of x plus delta x being an input to f, that's like an x2. This is x2 minus x1. This is y2 minus y1. Guys, this is just the derivative of f, but with the function g inside of it. And so what we end up with when we take our derivative here, and this is the part that's pretty cool, is that this limit, it's the derivative of f with g of x inside of it times the derivative of g of x. And that is what the chain rule says. It says if you have a composite function, like we did, h of x, and you want to take the derivative of it, that's what we want to do. You take the derivative of the outside function, f prime, but notice we didn't change g of x. We left g of x alone inside here. And then at the end, we multiply by the derivative of the inside function. So one of the notations we'll see a lot is that we have an inner function and an outer function, and the inner functions sometimes instead of a g of x, they just call it like a u, and so the u function that's inside there, which that's another way of putting it. And so you'll see in here like they do f of g of x, and they just turn that into f of u, and then they do f prime of u and that kind of stuff like that, multiplied by u prime. At the end, though, theorem 10.2 is really all about. It's saying, look, if you want to take the derivative of a composite function, derive the outside function, leave the inside function alone, multiply by the derivative of the inside function. Okay, let's take a look at maybe a composite function that we may see. I'm going to start with a pretty basic trig function. Okay, you can see like the sine function is the outside function and 2x is the inside function. Okay, so when I'm taking this derivative using the chain rule, because I got a function 2x that's inside the sine function, okay, what we're saying is say, okay, what's the derivative of sine? Okay, well, we saw that last week, so we know that that's cosine. So take cosine, okay, and leave the inside function alone. But now that you've done this, you have to multiply this all by the derivative of 2x, which of course is 2. Okay. So we get 2 cosine 2x for the derivative of sine of 2x. If you have a different function, let's say g of x is the square root of 3x squared minus x plus 1. Okay, so my outside function is that square root function. My inside function is the 3x squared is the polynomial. Okay, now remember, we don't have a rule for square roots, right? There is no rule for that. But there's a power rule. Okay, so this 1/2 power is the outside function. So bring down your power. Subtract 1 from your power. But then the chain rule says, hey, you're not done. What's the derivative of the inside polynomial? Oh, okay, so 3x squared, the derivative there, bring down the power, multiply by the 3, and you're going to get 6x. Okay, the derivative of negative x, negative 1. And what happens to the constant? Well, its derivative is 0, so it just derives away. And so if I'm going to clean this up, and I really should do a little cleanup here, 6x minus 1 is in the numerator, 2 square root 3x squared minus x plus 1 is in the denominator. Again, chain rule, okay? Chain rule says, look, you have to pay attention to that inside function, okay? You just have to, okay? This actually gives rise to one of our rules, something called the general power rule, okay? Because now, for the general power rule, what we're going to say is say, okay, look, our function, y is going to be some function of u to the nth power, where u is some function of x. Okay. So what we call the general power rule, the derivative with respect to x of u to the nth power. Okay. Well, notice I know u is a function of x. I just don't know what the function is, and there's a mismatch here. It looks like just u to the nth power. So yeah, and u to the n minus 1. But there's a variable mismatch. This is dx. This is a function u. That's how I know I'm not done. I have to multiply this by the derivative of u with respect to x. That's what's called the general power rule. If you look in your book, I think you'll find it's written like this. They use a Newtonian notation. I use the Leibniz notation. Same thing. Okay. You always start with the outermost function, do its derivative, then do the inside function. You might have multiple functions. Okay. We might run into a 3-layered or a 4-layered function. Okay. If you have like y equals the sine of the square root of x squared plus 1. Now there's 3 functions, right? Okay. What's the outermost function? Well, if you're thinking about the order of operations, the outermost function is the one you would do last. So if I said, hey, x is 2, solve this for me, what's the last thing you would do? You would do the sine function last. So that's the first layer we peel away. Okay. We start with the outermost function. We start with the cosine or the sine. So we get cosine the square root of x squared plus 1. See, I didn't change anything else. But now the chain rule says, wait a minute, you're not done. That inside function, square root of x squared plus 1, what's its derivative? Well, we know the square root has a derivative of 1/2. Leave x squared plus 1 alone. Subtract 1 from the power. Chain rule says, we're not finished yet, because there's an inside function there still. X squared plus 1. What's that derivative? Oh, that's just 2x. And now we clean this up. You see how we have a 1/2 and a 2 multiplied together? Those will cancel each other out. And so we get the cosine of the square root of x squared plus 1 times x over the square root of x squared plus 1. Yeah, the chain rule, it really adds a layer of complexity to our other derivatives that we had previously. And unfortunately, it is unavoidable. So when you start looking at the front cover of your textbook, you're going to see all those derivative formulas, okay? And each one of those derivative formulas is actually written so that you don't forget the chain rule. So, if you take a second here, if you've got your book handy, flip to that front cover, and pick any one of those formulas. Now, we really don't know a lot of them. Well, we know a few of them, but, we haven't done anything like 17 through 21. We haven't done 9 or 10. And don't worry, those aren't going to come up for a while. So you've got some time before you have to worry about those. But even just like number 11, a derivative of sine of u. Okay, and they're reminding you that, and look, it's taken with respect to x. So they're saying, hey, that's cosine of u times u prime. That's so you remember the chain rule. Okay, I'm telling you guys, the chain rule shows up all the time, and we just have to be aware of it, and slowly but surely just peel back the layers. Here's this one has, this equation here. There's 3 functions there that are, kind of nested together. I think of it like, there's those dolls. They have those nesting dolls, where you take the one doll off and then you open it. There's another doll inside, and you open that little doll up. Those. I think they're from Russia or Poland. I can't remember exactly. I think they're Russian. But yeah, they're nesting dolls all inside there. We call these nested functions, and that's the same idea. So you do one at a time. Conversely, some people who really like Shrek would say, well, then derivatives are like onions, right? So they have layers, but that's another thing altogether. So, all right. Well, thanks guys for hanging in there. The chain rule is a very, very important topic for us. This is how we do that. The derivative, it just comes from the limit. Okay, we just have that little multiplication like I showed you in here. It's going to be something we use quite a lot as we go forward the rest of the year. Hopefully that made some sense to you. And when we get to class here on Friday, we'll be doing a lot more work with the chain rule. So thanks so much for watching, everybody. Have a great day.